I want to introduce Kevin Bowling and Pavel Snagovsky, both with Limelight, and I'll turn the time over to you guys.
Thank you.
So, as it was said, I'm Pavel Snagovsky, and this is Kevin Bowling. So we work for Limelight and wanted to tell you the story how we end up using Salt and what we're doing with it. So a few words about Limelight. We are the top tier CDN. We have a video platform and object storage on top of the CDN. We are roughly 10 terabits ingress. Oh, I'm sorry. 10 terabit ingress with our own international backbone, and that's what differentiates us from most CDNs.
So we have on order of 100 data centers in various topology, and on order of 5 figures device count, so that includes servers, switches, and other network devices. You're most likely using us every day without knowing it. So most of the major commercial operating systems and mobile phone operating systems use us for updates. We're very big in large object delivery for video, and we do website acceleration as well.
So we have 24/7 engineering presence, obviously. So we're a big company. So we have diverse, very talented teams with variety of skill levels. So our team manages the automation in the company, and it includes configuration management.
With that, we also have a diverse infrastructure. A large part of our edge is running on FreeBSD, and we'll go into that later on. So about myself, I'm a software engineer at Limelight Networks, and we work on this integrated team that does tools and automation and monitoring metrics, things like that. We're also doing the Salt work and some of our previous configuration management.
So besides the FreeBSD, we also have a large installation of Ubuntu, Debian, some CentOS, and some Windows. So we have to support all of it and few other operating systems. I'm a systems engineer on the same team. Today is, by the way, my wife's birthday. So it's a big sacrifice to be here. First we would like to talk about challenges. What really, about the problems, what motivates us to actually seek for a new generation for configuration management. We're using across the company multiple configuration management solutions. We're using CFengine 2. We're using several installations of Chef with different code base. And all of these tools are aging, and the teams and the company are looking for more ways and better ways to automate things.
With that, we also had a lot of reliance on tools and scripts that were kind of written ad hoc. Especially on the CFengine 2 side, we had to kind of reinvent the wheel to do something as simple as templating. So this kind of increased our operational costs. It's hard to figure out how all these things tie together when it's so custom and laborious to work in.
So basically, we're looking to standardize a lot of our tools, standardize our configuration management, just increase efficiency, increase our operational ability. So these are really the motivating factors for us to seek for a new configuration management solution. And so the challenges we had to handle, we had to really safely eliminate most of the technical debt that we have, and just really address the challenges of our scale, address the challenges of our diversity, and really provide better tools for operations.
Obviously, from our intro slide, we're a high-scale company. That's kind of our bread and butter. So we had to, figure out how to make our configuration management scale, and this was a very big deal in its own right.
So one of the biggest challenges was perhaps just make the entire infrastructure to be operational. Real-time feedback from the infrastructure, real-time changes. For massive infrastructure, it's a large challenge. It has to be flexible. It has to really solve a lot of operational problems. So operations were one of the biggest challenges that we had.
We also wanted to wrangle some of the platforms and kind of define how those would be supported. Offhand, we've got 2 flavors of Ubuntu long-term support, 2 distinct versions that we'd like to support. We have CentOS, we have FreeBSD, and we also have Arista EOS on our top-of-rack platform now. There are some other things out there, but those are our primary targets for this project.
I think another challenge that we didn't mention was really variety of products that we offer, and all of these products managed by different teams. So this multi-tenancy is another challenge that we had to face.
So the end result of this, we're trying to increase our stability and efficiency as a company. These are important to our customers and to us as shareholders. And we also want to, kind of document how everything works. Limelight's been around for, I think you said 15 years? 14 years. So, we've accumulated, technical debt or whatever you want to call it. And this makes bringing in, new people hard and spinning up new projects or products hard. And we think we can, make that easier with configuration management and with Salt.
Also, documenting is very important, and have standard ways of doing things is important because we have very large operations team.
So how we got to Salt was an interesting process. And, we have to kind of give a shout out to the folks, our management chain, for allowing us to go down this direction. Salt was something that none of us had production experience with when we started. So we went through a fairly rigorous process to select Salt, and we'll go into that.
It also started very interestingly. So we were talking with I was talking with one of our VPs about the challenges that we have, and I would like to give credit to our leadership. They fully understand that it has to be engineering decision how we should be moving forward. And we created a team, assembled a team of engineers that picked the products that possibly could address our challenges. And that team built fully functioning environments with Puppet, Salt, Chef, and CFengine.
So that took us do you remember the time scale? I think it was like a month or so. Excellent.
So last summer was a time when we started going through our selection process. So we are relatively new to Salt. And we were given sufficient resources to actually make that selection. And engineers were the ones who actually choosing the product.
So some of the real deciding features for going with Salt, in my opinion, and I think our whole team agrees, it's a paradigm shift to build CM on top of an orchestration platform. If you look at the other systems, they're basically running a cron or a scheduler, and you're doing this synchronous process to apply your changes. and you're limited by that. And there are, workarounds. That's really the term I would use to get around that. But Salt kind of flips that on its head, and now you have this, system that you can push changes out and react to changes.
Right, so it's a self-aware infrastructure that reacts to events, infrastructure with, from which you can get real-time feedback. And for us, it was one of the biggest motivating factors for Salt. Plus, this bus could be used very nicely for operations.
So we also wanted to, have wide acceptance of the solution. We need to sell this in a way to other teams, other engineering teams. And we liked what we saw with Salt. The barrier to entry seems fairly low.
Especially compared to the other tools. Yes, starting with Salt seemed to be very, very easy. It was in our experience and feedback that we are getting from our teams. It's great.
So one of the key features there is the declarative state files. Your main entry point is YAML. But on the other hand, there's a ton of flexibility for people to go out and create modules, reactors, new types of states.
Significantly extending the functionality of Salt. And that flexibility is really another big motivating factors. Vibrant community, so while we were running Salt, we were submitting a few patches, bug fixes, and all of it was very quickly merged in.
We also, like Pavel was saying, when we were doing our initial bake-off, we were actually running RCs of 2014.7, and we caught a handful of issues in there and either reported them to the bug tracker, the GitHub issues, or sent PRs for fixing some of this stuff. And that was a very smooth process. We were pretty, I think all of us were pretty impressed with how easy that was.
Scalability is another big motivating factor. So with our global footprint, scalability is really, really important. So other tools, no near to the scalability options you have with Salt.
So there was a quote we overheard at the Salt Advanced Concepts talk yesterday. Tom Hatch said something along the lines of, languages don't scale, algorithms do. And that really reflects our experience with Salt. We're solving this with architecture and topology rather than fast machines or really vertical scaling like we might have had to do with some of the other things we looked into.
So to address all the challenges that we had to come up with solutions. And so what we are going to talk about today is the workflow we came up with, how we're addressing the multi-tenancy, both for our teams, for our products, and for our infrastructure, scaling with the architecture, how we architected it.
We'll also go into how we actually get Salt onto our systems to manage them. That's something that seems simple, but it's actually, there are some interesting things going on there when we have these other systems at play. We've developed some of our states using the alternative renderers in Salt, and we'd like to share and really highlight how useful those are for people. And we'll also go into what we're doing for reporting here at the end.
So we will start with the workflow. We had to come up, for our large team, we had to come up with ways to safely promote code, safely test code, and safely deploy it. And we really felt the need that we need to design the workflow and how we develop and manage Salt.
So we're calling this the F-master, and effectively what we're doing is we use GitHub Enterprise as our state repo store. So when somebody forks that and does some development, they open a pull request, and we're taking that pull request.
That pull request simply creates a new future branch. So fmaster stands for future master. So development will be happening in completely segregated environment, and it's fully automated how we spin the new environments, how we spin the new fmasters.
So we spin up a salt master that follows this feature branch, and this allows us to develop the entire CM stack. We can change the way that salt master runs. We can deploy new states into that feature branch, and we can do full, production end-to-end testing on that development branch.
So, and consumers would be able to put any set of nodes or any environment on that fmaster to actually test and develop what they're developing.
And the way this is built is, again, we're consuming the GitHub webhook with the Salt API, the hook point. We have a reactor that then...
so it triggers a Salt event, and we're picking it up with the reactor, and we then running some custom states that spin the container and set up the fmaster. And
it's fairly easy to unpack the stuff in that webhook, and we can go out and fetch or confirm the validity of that request. The Salt API has been really, really fantastic.
Right, so it's really example of event-driven setup.
So the other piece of this workflow puzzle is how do we promote those changes in those pull requests into our, our mainline, and we have a tool called LEC, and this was kind of the same way we investigated these configuration management tools. We went and looked at tools like Garrett and Fabricator to see how we could do peer review. We liked the capabilities of those tools, but they moved the conversation about the pull request from GitHub Enterprise, which, other than this gating, did everything we needed.
So we had to introduce another tool. So we decided to actually create our own custom solution, which ended up not to be that hard. So there's a person here, Krista Christensen, who developed LEC. So what the problem that that tool solves is really safe code promotion. So it solves really access control and merging.
So we've got a screenshot of this, and we'll go over that in a second. But I'm going to continue on. So we also use the Gitfs backend to actually pull these branches into the masters. And we had to figure out how we could create different repos for different teams. As our team runs the shared repo that does the core management of the system and the configuration management system itself, then we're using other Git repos for product teams where they can override things. They can do their own workflow if they have different needs than the one that we've come up with.
Right. So the way we address the multi-tenancy, product multi-tenancy, is we have multiple repositories. So each team would have their own repository with a code that's been added to another Gitfs to our master. So teams, in this sense, are quite independent in their development for their product.
We also created initially during the bake-off, but we've continued this onto our production environment, a Vagrant setup where we can spin up our supported operating systems and the Salt master. And you can do that. That's kind of your first point of interaction with the system. You can use that to develop the configuration management system itself, or to port or enhance an existing service or product.
Right. So our Vagrant setup spins all the supported operating systems, and you can do some testing and quick development, play with Salt, whatever your needs are. You can do it all locally, and we support that environment. So a few other decisions that we needed to do for the workflow we decided not to heavily depend on pillars. We're using pillars mostly for ciphers. GPG ciphers is practically the only pillars that we are storing. So we decided that we will go with less dependencies, and data should live directly with the states. And the few reasons that we decided to do this, multi-tenancy is one of them. So we wanted to manage the way parameters are being overwritten and attributes or data being overwritten. We wanted to manage it with our custom tools.
So we're not settled here yet. We think we might need to make a custom module to do some of the parameter merging and overriding. But thus far, it's actually worked well for us to put the data either in our state repo or pull it from an external source and use map files in the state repo.
So here's the example of how LEC actually functions. So LEC interacts with the APIs of Jenkins, APIs of GitHub, and it really, the owner, LEC is the owner of the repository, of our salt state repository.
So this is on public GitHub if you're interested in using this. But it's effectively like a rules system. So you'll see some of these comments say, you know, your PR's title isn't correct. It chooses somebody and mentions them by their username, so they get an email notification to go look at this pull request. And then, like Pavel was saying, this is the final, this is the thing that actually does the git merge. We don't press the merge button. There's actually, you know, that's limited by the repo's permissions to this LEC user, or Jenkins user in this case.
So what LEC also allows us is to create very, very granular permissions system. So we can control each directory, and which GitHub doesn't really allow. So we can control every object within the repository itself and set custom permissions on it.
So Chris followed the owner's file format, I believe, from the Chromium project. And this is where you can say, you know, a certain person is, or a certain list of people or group are responsible for this, you know, particular piece of the state repo. And that's what in turn selects them at random for the review here. So it turned out really well, and it's not a lot of code, I should point out too.
So another challenge in the workflow is testing. So we're doing basic lint, PEP8, dry run, and state validation. So the way we are doing the state validation is with a state show SLS, and updating the list of states with the CP list states, and simply iterating it, rendering every SLS, validating everything that we have. And it is presented here. This is the example of the make file that we have. And we also have pre-commit hooks and stuff like this. But in here you can see several types of validation of the states. We have our own custom script, and there's a snippet out of that script, how validation is being done.
So when you open the PR, it's actually running all of these things in the make file, and that's being fed back, you know, with Jenkins to the pull request, and LEC takes that into consideration for whether or not it's acceptable to merge. This way, if you have a syntax error or something, it's actually not possible to merge your PR. We want to keep integrity of the CM system intact at all times. We have an open, you know, thing to work on it as far as actual functional testing of the states themselves. We're, you know, still kind of exploring that.
Right. So there's a few more things we have in mind to do on testing. So this is just the beginning. Scaling. So scaling is biggest thing for us with our footprint. And Salt has a wonderful architecture to allow us to create custom topologies. And that's what we are utilizing here. we're using Syndics heavily, and
we really liked the custom topology. What this allowed us to create was no single points of failure. We can fan out the workload, and the configuration absolutely has to be dynamic. We can lose connectivity to data centers for a number of reasons, and we need to be able to survive that, the system. We can't have 2,000 machines spin up, and hit a master and just tank it, because that kind of stuff happens fairly regularly in our environment.
So we also ended up using completely separate environments for production and everything else. So production lives on its own. We decided not to use a built-in environment feature of Salt.
We also had to solve targeting, and Salt really helped us with this, kind of slicing groups of devices, either for orchestration or for configuration management. It also helps with things like diagnostics and audits. This is a real key win for Salt. We can go out and ask machines, what version of a package they have installed, and get accurate information as of when that command was run.
Right.
It's been really helpful for security patching and things like that.
Yeah, flexibility of targeting is great in Salt.
The master clustering.
Oh, right. So, well, really looking forward to the new master clustering feature that is coming up. It's actually tied to the RAID that is coming. So what they really planning to do there in Salt, they are planning to simply create a secondary bus for interaction of the masters. I'm not sure why it was not done yet, but it is really a feature what we are looking for.
So getting Salt onto the systems is kind of challenging for a number of reasons. Like we said, we have these existing tools like CFengine and Chef in play, and we also have to kind of accommodate the product teams and what they're doing, and gradually move things over. We can't induce outages and problems by moving to Salt. So we did this two ways. I'll speak to CFengine. I'm most familiar with that. We have a policy basically that installs a Salt package, easy enough. But then we also have to detect what is then managed by Salt. So we use different types in the agent configuration to control that. And likewise in Salt, we can say this is done with Salt, so don't do it with CFengine, or this is done with CFengine, so ignore it in Salt. And that allows us to slowly move things over as it's acceptable.
So we are doing similar things using Chef. We actually not lucky, but it's beneficial to have a previous configuration management system. It really simplifies a lot of migration. A lot of us, as we mentioned, a lot of us have background with different configuration management tools. I have very solid background with the Puppet and Chef. So with Chef, we simply have a Chef cookbook that deploys Salt and then manages the gradual migration. So you gradually manage more and more things taking it off Chef.
And we're also just using a custom Bootstrap script. It's basically a cut down version of Salt Bootstrap. We're using our own repos and native packages everywhere, and we like that. It's gone very well. As we managed more and more of our infrastructure, we started to investigate the different renderers, and one we liked a lot was PyObjects.
Right, but so that's another great feature of Salt. So the custom renderers, and we didn't find the use for our own custom renderer yet, but we're using PyObjects and GPG renderer a lot. And we would like to share the example of the way we're managing our roles with the PyObjects renderer. So basic idea here is that we have our inventory system, and inventory system is a source of truth for what the system's supposed to do. We generally call it role. And role is directly the name of the role directly mapped to the name of the state, so they has to match. So here's the examples. At the very bottom, we have example of the top file. So we simply iterate over the grains for the roles, adding them in. That's how simple it is. It's all dynamic. But what we're using, where PyRenderer is great, is it's really object-based interface that allows you to interact with Salt very, very easily. So for example, this code would take in a YAML and Jinga, it would take perhaps at least 60 lines. And with the Py objects, it's extremely simple. What we basically are doing, we're checking if our grains for roles are set up. If they are not set up, we simply execute next state, which is the set, and set grains simply obtains the grains from our inventory system. As you can see, it's actually using the runner. And the reason we chose to use the runner, we wanted to have credentials only on masters, and we have specific nodes interacting with our inventory system.
So we're working on making the roles system fully event-driven. Basically, what we have to do is change our inventory system to push data to Salt, and we can simplify this down even further. But as you can tell, it's not a lot of code to get this dynamic configuration of the states that a system's running.
Well, in fact, the changes necessary for our inventory tool, which is called Cornerstone, to actually generate event on a Salt bus are already in QA. So we very, very soon have it completely full event-driven, but in the meantime, we had to write this verification that being scheduled on a specific periods that just verifies the roles in inventory and in grains.
One more. So the final tier of our solution is reporting, and basically we did this with Elasticsearch. We're taking data off of the Salt bus with this thing called Salt Events D, and we've got, basically we forked that and added an Elasticsearch worker to it. This lets us, for instance, take things like the job information and put it into a search index. Then fairly trivially, we can build these dashboards with Kibana. And not only do you get kind of the graphical representation, but we can go in and do search queries at the top there and see what jobs are complete on a node, or what was broken as far as the states that ran on that node. And because Salt's asynchronous, this works really well in a large environment. You don't, when you run a high state from the command line or from the schedule, you're not necessarily going to hang around and see that complete, but you can go in and look with this reporting in aggregate and see what's going on.
Right, and this is just the beginning for our reporting. We have few ideas that we would like to implement to provide more tooling for our operations and our teams. We're also very excited about new features that are coming in Salt 2015.2 with the rate and beacons. Beacons really change a lot of things. Engines, writing new engines would be awesome. So we're very excited, and this is the really beginning stage for us to migrate to Salt. We're just in the middle of this process right now, but we love it so far.
We're in talks with the SaltStack company as far as their enterprise dashboard. We're kind of waiting and seeing to what they do with that, and we look forward to them creating an interesting product that we could possibly use.
Yeah, at a reasonable price.
Yep. So in conclusion, Salt helps us run a large portion, a significant portion of the internet, and we want to thank the Salt community, everybody here that's part of this, SaltStack the company, our Limelight team, the folks that are here, and also the people that are doing real work today.
Right. We started contributing to the Salt project, and we're looking forward to contribute more to it.
With that, we're hiring. I guess we should throw that out there.
We're really hiring, so yeah. Feel free to contact us. Feel free to chat with us or buy us a beer.
And we'll open it up to questions from the audience.
So when you guys spin up a new F master, then you just overlay the code base when that's finally merged in onto your existing code master, or how do you handle the negotiation?
Okay, so the question was, when we spin up an F master, how do we merge that back into mainline, and how do those minions become reattached to the mainline master?
So on the first part, it's just a branch that later will be merged into the master. So and on the second part, the F masters will auto-generate the keys.
So that's important to point out. We're actually using the auto-accept key negotiation currently. We're going to look into that in the future to see if we can do something more, reliable and secure. It's working for us for the moment, and it's not a regression based on our previous solutions. The question was, do we run the minions as root? And yes, universally we are running them as root currently.
Well, in many ways you kind of have to, but yeah.
Back here. So the question was, how do we kind of live with the fact that at any given time, minions won't necessarily be available and responding to Salt? There are a couple things we do. I mean, we are using a scheduler to run our high state, and that we've had a lot of proven success with that with CFengine and Salt, running on these time-bound things. That guarantees that we'll eventually get convergence of the platform, to a high state. The other problem is kind of a reporting problem. You need to go out and see what's going on. And I should highlight, we have a pretty extensive monitoring framework in play to know when these things are going on, like why a data center might be unavailable or why a host might be unavailable. We're going to start using the Kibana stuff to get actual Salt insight there.
Right, but monitoring is really the key there.
Yeah. So we have a 24/7 presence, operations presence. So if a system goes down, we're pulling it from service, or we have operations engineers, looking in and seeing what's going on and trying to fix that. There's definitely a human element there. Over here.
No, not logs.
The question was, do we monitor the Salt key logs, activity logs?
No, not at the moment. Yes, but and the reporting that we have, once we'll be adding more filters on that reporting, that would be the way we would monitor it, as opposed to monitor actual logs.
We do ingest the actual jobs running through the bus, so we do have a audit trail of it. We're not necessarily using that for anything yet, though.
So far we have about 6,000 minions deployed, and this is just the beginning, and they run mostly some of the core services. So we started dealing with the products, but it's not in production, and it's still coming up. Probably by the end of the year we should be covering practically everything.
Back here first. Okay, so the question was, we have multi-master and Syndics. How are we assigning nodes to that? We actually use a map file currently, and we're dynamically generating that. So we try and choose the nearest pop Syndic, and then based on latency, one or two other pops, and we do failover.
But we also have in the works actual modules that will manage which Syndic or master minion has to use. So, but it has not been complete yet.
It's somewhat static currently, and with the module, we'll be able to do that in real time, I think.
Yeah, the source of truth, are you planning on using something that's database driven?
So the question was, what is our source of truth, or what are our plans for that? We have this existing system called Cornerstone that's basically the physical description of the device, and then it uses tags to describe the logical configuration of the machine.
Roles, pretty much.
So exactly, those get wrapped up into roles in Salt, and that's generally how we do node assignment, role assignment to a node. The other data we're trying to keep in the state repo currently.
We also actually getting quite a bit of metadata from the inventory system and placing it into grains.
Yes.
And we're keeping it in sync. Another thing, we tried actually external pillar to use our inventory system as a source of external pillar, and we decided not to go that route. So later on, then basically, because of the external dependency, because of the scale and stuff like that. Anybody else? Yes.
So in terms of
Yes, each machine could be Snowflake. So again, it's each object in our inventory system would have a set of roles, and those roles could vary from anything. It could be, for example, LXC host. It could be a specific product. It could be a Salt master, Salt Syndic. So this would be a role. So we have variety of roles. The amount of roles is significant because our infrastructure is very, very diverse, complex.
So the multi-roles allows us to accommodate these different product teams, and it lets people manage things the way they want to. We do have a large set of boxes that are basically a single role for various products, but we also have to allow people to build these more complex hosts for different products. Exactly, yes. The question was, our roles are equivalent to CFengine classes.
Yes.
So we're using Salt to do the requisites or dependency management. There is opportunity there for conflict that we haven't really enumerated yet. So far, it hasn't been a problem. I think in one of the tutorials they mentioned the state graph tool. We're going to deploy that probably into our inventory system so you can see what's going on.
We were considering to add it to LAC to have some sort of validation if there's any overlapping, to LAC the tools that we're using to do the merges and tests. But also, in our previous experience with other configuration management tools, we actually never run into this problem before. So whoever describing the role and developing that role, it is their responsibility to make sure that that role is fully in a box. Well, it's fully pluggable. So if you have something more generic to manage, it has to go to the core. So a quick example to
Repeat
help.
the question first. So the statement was that we have, generally you have a base operating system configuration, and then you have higher and higher order stacks, where generally you want to allow some things to be overridden, but you might want to prevent some things from being overridden. Go ahead.
So first of all, we allowing the customer to actually override anything that is being included on top. So, and that's the way we manage the attributes. And second of all, let's take a quick example here. So, for example, we're deploying 3 services, and one of those services are trying to use the same port to listen to, right? So that would be a good example. So it's really the responsibility of the customer to figure it out, and so they should figure it out in the F master, in the future master, that might conflict. And we have a mapping of all the ports for each application used. So none of it should be overlapped. So and the way to address it would be, yes, just create more mapping, I guess.
So in general, this is one of our scalability vectors, is teams or people. And we're trying to push these things out to the service owners. These are engineering teams. They're people that can make these decisions because they're the ones that can best make that decision on how to co-locate services or how to repel things and things like that.
One of our big goals also with Salt, we want Salt to be used and everybody across the engineering to be comfortable using Salt. We're very, very working hard to make it happen. So we're working on a base, we're working on creating platform. So, and we will work with the teams to help them to use it, utilize that platform.
So we, in our case, we would push that out and let the application win. We're not going to prevent people from shooting themselves in the foot. There's too much going on for our team to manage all that. We're providing a baseline and then pushing out to as far as possible. So the question was, we have the set of repos and one set of masters, and that we have our states go to all of the masters, and we're using Gitfs to do that.
Yes, and to your question, yes, it is true. So we were considering and discussing to actually use segregated masters per product and just have a core repository plus the repository for that product, and we decided not to go that route yet. So right now we're using it all squashed into one.
Yeah, so the question was, how do we control rollouts? And there's probably 2 different distinct answers to this. One is targeting. Salt has the rich targeting features, so you can change the role of a system or set that in our inventory system to follow the new tag. Do you have any other?
And another one with the existing configuration management, you simply, that role that manages the Salt installation, it would have exclude list what is managed already by Salt. So it would prevent, for example, make sure that the cookbooks are not added as a dependency or anything like this.
We could use our F-masters to do a rollout as well by targeting again, using Salt targeting to say pivot to this F-master, and that will cause whatever states to run to do that deployment. Then when we're satisfied, we merge that branch in and return those systems to the main line. there are some options there, and we're not fully fleshed out there as far as our policy yet. Okay.
Oh, okay.
Thanks.
Thank you very much.